Okay, so we've all talked to chatbots, right? You ask a question, you get an answer. It's fine. But what if that AI could do more than just talk back? What if it could actually take your request and do something with it? That's the huge leap we're talking about today, moving way beyond basic chatbots and into the wild, fascinating world of AI agents. So let's get right to it. This is the fundamental difference, right here. A regular language model, it's pretty passive. It takes your prompt, thinks for a second, and gives you back some text. An AI agent, though, is active. It gets your prompt, and then it starts a loop. It thinks, it takes an action using a tool, it observes what happened, and then it thinks again. It's a real problem solver, not just a fancy text generator. So here's the jury we're going to take. We'll start with the absolute basics, the core components of an agent. Then we'll see how an agent is born, how it actually thinks. From there, we'll get into how you make them seriously powerful, tackle the really hard part of getting them ready for the real world. And finally, we'll zoom out and look at the future, a whole ecosystem of agents working together. All right, first things first. What actually makes an agent an agent? Let's cut through the buzzwords and look at the real building blocks. The easiest way to think about it is to imagine a person. Every agent has a brain. That's the large language model doing all the reasoning and planning. It has hands. These are the tools it can use, things like a web search, your calendar API, anything really. And, connecting it all, it has a nervous system. That's the code, the orchestration layer that lets the brain control the hands and manage the whole process. So you've got the brain, the hands, and the nervous system. How do they actually work together to get something done? Well, it all comes down to this really simple but incredibly powerful loop. This is basically the agent's heartbeat. First it thinks. It looks at your request and makes a plan. Then it acts. It picks the right tool for the first step of its plan and uses it. And finally, it observes the result. Did that work? What new information did I get? And based on that observation, it loops right back to thinking about the next step. Think, act, observe, over and over until the job is done. It's not about one perfect answer. It's about a process. Okay, so having one agent that can think and use tools is already a massive step up. But what happens when a task is just too big or too complex for one little agent to handle all by itself? And this is the exact problem that every developer hits. You could try to build one super genius agent that does everything, but that gets messy and unreliable fast. So the real solution isn't to build a bigger brain, it's to build a team. And managing a team of agents is kind of like managing a human project. For really flexible tasks, you might have one LLM-based manager agent that delegates work to others. If the order of operations is critical, like booking a flight then a hotel, you use a sequential workflow. If you can do a bunch of things at once to save time, you run them in parallel. And if you need to refine something over and over, like drafting a report, use a loop to keep making it better. Now, to make these agent teams truly effective, you give them superpowers. You can build custom tools that are specific to your business. You can even give agents other agents to use as tools, which is pretty wild. And most importantly, you give them memory, so they can remember what's happening right now and also learn over the long haul. And let's be clear, memory comes in two flavors. You've got sessions, which is like a temporary workbench. It holds all the context for the one conversation you're having right now. Then you have memory, which is more like a long-term filing cabinet. It stores key insights from all conversations, which is what allows an agent to actually learn and get smarter and more personalized over time. And now, we get to the hardest part of this whole journey. Honestly, building a cool prototype is one thing, but making an agent that's safe, reliable, and actually ready for the real world, that is a completely different beast. This is what we call the last mile challenge. This quote just nails the problem. With normal software, you look for bugs in the code. But with an agent, the code can be perfect, and it can still fail because of a tiny flaw in its judgment. It's unpredictable. It can pass 1,000 tests and then fail in a completely new way out in the wild. That means you need a whole new way of thinking about quality. So how do you test for these flaws? You need a two-step strategy. First is the black box view. You just look at the final output and ask, did it work? What went wrong? If the answer is yes, something went wrong, you then switch to the glass box view. You open it up and look at the agent's entire step-by-step thought process to figure out why it went wrong. Ultimately, you're measuring quality against 4 main pillars. Is it effective? Did it actually do the thing you asked? Is it efficient? Did it do it without wasting time or money? Is it robust? Can it handle curveballs and unexpected errors? And the big one, is it safe and aligned with what we want? That last one is the absolute, non-negotiable gatekeeper. This all feeds into what's called the quality flywheel, a cycle of constant improvement. You start by defining what quality even means. Then you add instrumentation so you can actually see what's going on. You evaluate that whole process, and this is the most critical part. You build a feedback loop. Every single failure gets automatically turned into a new test case, so the entire system gets a little bit smarter every single time it messes up. So how much work is this last mile? Well, get this. For a production-grade agent, about 80% of the total effort isn't even about the cool AI model. It's about the infrastructure, the security, and all the validation required to make that agent trustworthy and reliable. 80%. So let's say we can actually solve these huge production challenges. What does the future look like then? What happens when we go from small teams of agents to millions of them, all out there on the internet, all needing to work with each other? Well, this massive collaboration is probably going to be built on open standards. Two big ideas are already taking shape. There's agent to agent, or A2A, which is for complex stuff, like one smart agent delegating a whole project to another specialist agent. Then there's the Model Context Protocol, or MCP, which is for simple, quick tasks, like an agent just needing to use a calculator tool to get an answer. And that really brings us to the final mind-bending question. We've traced the journey from a simple chatbot to a single thinking agent, and then to teams of agents. So, what happens to our world, to the way we work, to how we solve problems, when millions of specialized AI agents can find each other, understand each other, and collaborate instantly on any task you can possibly imagine?